Okay, so day 8. Day 8 looks like something that was in the puzzles last year as well, writing our own computer code. Probably an int code machine again. No, it isn't an int code machine. It's a boot code parser. So we get 1, 2, 3 instructions that we need to run. Jump to the next, jump to the previous, accumulate the accumulator and a no operation, and then okay, so that code parses it. Let's go through, and then we go into this deadly loop, infinite loop, and just before we hit immediately before we hit that infinite loop, we need to print out the value in the accumulator. Run your copy of the boot code immediately before any instruction is executed a second time. What value is in the accumulator? Oh, let's see. Whoa, that is big enough. So we probably want to start with our example program. That sounds probably good. So let's see what we can do. Probably this code is going to be revisited a lot of times, because if I know anything about the advent of code, it will build on to this computer we need to build, this code parser. So let's go to day 8. Come on. Of course, we want our skeleton. We need to read our code. I'll just pause the video while I set this up and bring the test files and the real puzzle files over. Okay, so I have added the 2 input files, the big one and our little test program, and set up the initial standard scheme to read that file into the stem we have called prog. So we need to parse this program and run it depending on the different instructions we find. So we start with the basic loop. Do I equals 1 to prog.0. That's the amount of lines in our program. I'm expecting we're going to get some functions in to do the actual stuff. And we better parse our prog.i into the op. Well, op is good enough for operator, right? The operation, a space, and then the, what do they call that? Argument. Op and arg. Let's just see if it works. Say instruction at I. Op. Come on. Arg. That should basically print out our program with line numbers. Of course, we break it already. Quote, 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 quote. That looks good, doesn't it? Oh, probably we can't do. That's a protected word, right? Operation. AR. Let's keep it short. Do what? Do what? What did we do wrong here? Well, first of all, we need to make sure we do day 8's input. Always nice to see this struggling. And then do, and this end is a weird color. So there's a quote, 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 OP. That looks better, I think. Yeah. So now, of course, we can't go back to forth on the line numbers of our code, because we need to take into account that we have these jumps and we have an accumulator value. So let's start with that one. Accum equals starts at 0. The accumulator starts at 0, yeah. We read that correctly. So, we also have because we can't do the do loop, we just need to set the instruction to where we want to be. So, we will call that NI for next instruction. While probably we need to keep on doing this, right? Yeah, NI. Start the first instruction, print that instruction, now we see what it is, so we do a select and otherwise do and probably say add unknown instruction, not instruction, operation top. And we'll probably leave the loop. Yeah. So what do we have when op equals ACC, then I want to make this a function. Yeah, then what does that do? If it's ACC, it increases or decreases the accumulator, and the next instruction is the next instruction, not jumping or anything, so you can just add to the. Let's not write functions yet, let's just do it inline, do it. So when it's ACC, then accumulator equals accumulator plus whatever is in our argument. I'm hoping that the plus minus signs will pick that up, and the next instruction equals the next instruction plus 1. I'm just going to hop to the next. Right, repeat, and see when our operation is JMP, it jumps, so jumping, then our next instruction is what? Relative to itself. The next instruction executes is found using the argument as an offset from the jump instruction. So jump to and skip the next instruction. So it just adds to the recurrent, so it's n1 plus whatever our argument is. And then we have a NOP that just does nothing. Do nothing. And we just go to the next instruction. Now this will give us the loop. But let's run it first. See what happens. Invalid command name while 1 equals 1. Doesn't it like that? Okay. Do forever. Let's see, follow our code. Instruction at 1 is no operation, we do nothing. Go to the next one, accumulator plus 1. We might as well print it. We take the next one, jump 4. So that goes 1, 2, 3, 4. We end up at ACC 1. That works. Then we get a jump minus 4. 1, 2, 3, 4. Accumulator plus 3. Jump minus 3. 1, 2, 3. Accumulator plus 1. Next one, 1, 2, 3, 4. I think we've already hit this point now, right? This will go on and on and on and on and on and on and on. So we better hit that attention key say hello, and then you might want to keep track of our current accumulator value here, and we need to keep track of what instructions we have done. So what does it say? After an instruction a second time. So we need to keep track of the ones we have, and we know that by ni. We'll just do this ugly xx is an empty string. Yeah, and we can do that here. We can say if the position of the xx, needle comma haystack, right? If I, position of I, the number, into xx is greater than 0, then do, and we hit the same instruction, say would go into infinite loop, accumulator equals exit. We already have the end. Else, if it's not in there, we can say xx equals xx plus a little space plus I. Let's see. Oh yeah, we can't use plus on strings. We're not doing Python. Just do it the ugly way and execute. We go into the infinite loop, accumulator equals 0. Let's search, and we can't do that if this is naive. This is naive. We have to do word index is 1 to words xx. Here we do found equals 0. If word xx comma word index equals ni, then do that bit. This is ugly. Don't need to do this. Is all good. And else we just add it. Let's see if it still works for our test code. Hopefully it still says 5. No. What? Rid of all these in between prints. I'm so curious to see if it works. 1489 149. Oh yeah. Right, clean it up and go to part 2. Clean it up. Jumping. We don't need to say we're jumping. We don't need to see we're not. We need the error code there. Do we need this? No. No. Run it again. Boom, fast enough. So, day 8, part 2. Copy day 8, part 2. That one.